Say, kids, what time is it?
The future.
Live from our home studios in Boulder Creek, California. This is Future and I, a.k.a. Al and Son. And Bobby Wilder in San Francisco.
Hey. Hi.
Hey, Bobby. All
Hey.
right. That's it. I look this way to talk to you, right? Is that right, Son?
No, that just goes off screen.
That's it. No,
No,
this
if
way
you want
is
to
when I'm
talk to
actually
Bobby,
looking at him.
look
that.
at
Okay.
Bobby.
There we go.
Look right here.
Okay. That's perfect.
Okay, isn't that great?
Yeah.
You can actually look at him. You and me are the
know.
two. We have to fake it.
Yeah, but we're next to each other, so we can get away with
Look,
that.
why don't you look at me right now? What happens?
Okay.
Yeah, hey,
Yeah,
it's
there you
right.
go.
It
It
works.
looks right.
It works.
looks right.
I'm actually looking at you. Wow.
Yeah.
Wow. Well,
Okay.
All right. You got-
Miracles of modern
yeah.
magic.
So you got to think about this stuff when you're doing video podcasts.
Oh god,
Yeah,
so
a lot of
hard
details.
to get it
man.
all right.
It's like that's why they used to have a crew for television. You know?
Mm-hmm. We're the crew.
Yeah.
We're it. We're every single member of that production
But the
team
good part
now.
about it is you really get to know it. Really, you get to see how we assemble a show. And when you see that and you look at other shows, you kind of see how they did it.
Mm-hmm.
And you can, because you understand how to create a show yourself, you can disassemble how others do it and be less vulnerable to propaganda. Because you can see how they made it up.
There you go.
Yeah.
That sort of reminds me. Who was it? I think Chevy Chase used to say something. If you don't like the news, go make some of your own.
Yeah. All
We're
right.
definitely guilty of that. We're
Yeah,
trying to make some of our own.
Or Adam Savage, or is it I reject your reality and substitute my own?
All right. Myth bust, let's go. What you got for us today, my dear? Speaking of busting myths.
I've got some topical news and some evergreen news.
Okay, well, where to begin?
Maybe a combination of the two.
Uh-huh.
Yeah, we'll start. I also got a couple other things I wanted to run by you in the audience to see what you think.
Oh, yeah.
Yeah, and Bobby,
Okay.
I've been experimenting with the AIs and helping me create various intros for the various segments.
Oh, really?
Right.
Oh, so
And
you've
for
got
the-
Aura today?
Yeah.
Something
No,
like
no,
that?
this is not Aura. No, this is 11 Labs.
Oh, uh-huh.
Right,
So
this is
should I
11
cut over
Labs.
to your 11 Labs
Well-
screen?
Okay, we go.
This is your weekly update from the front lines of AI.
That was kind of cool, huh?
Yeah, it's kind of cute.
It went from our What the Future logo to Aura.
Oh, okay.
Aura now has like a male newscaster voice. Did everybody like the picture of Aura? Did you see that we had
no,
Aura
I didn't see
up?
that. You
Oh
had
yeah,
Aura?
I had the
Oh,
picture
that's
of
right.
Aura up.
Yeah, I've animated her too. I'll show you some shots of that.
Oh,
later.
oh, I can't wait.
And yeah, this is an AI news report intro.
All right.
This is
I think we're
this is
going to
the
go
AI's
to
gonna-
here.
there,
Let's
here.
see. We're going to go to
listening to us.
T, and there's what we want to see.
Okay, here we go.
Welcome to the AI News Report.
On What the Future.
Space News.
Oh, I like it. Yeah, we'll have to get some graphics for that. You
like
got
that
any
one?
pictures we can use?
Yeah, sure.
Actually, I think you've got some really nice space news today. Don't you have some news about the
I
Milky
do.
Way?
There's a new space telescope going up. It's called
yeah.
the Nancy Grace Roman Space Telescope from NASA.
Mm-hmm.
And it will be the first telescope to primarily be studying the center of our galaxy. It'll be looking at the Galactic Bulge in particular, which
The
is
bulge.
a bulge. Yeah, the bulge is part of its core science objective is to really look at the bulge.
Now, isn't the center of our galaxy visually inside of what looks like a dark spot in the Milky Way? Doesn't it look like a big hole in the Milky Way?
It's kind of dark because there are clouds,
Yeah,
dust clouds.
that's what I thought. Yeah, the light from the center of the galaxy is blocked by all of the dust clouds between us and the center of the galaxy.
Yeah,
Right.
I mean, if we were outside of the galaxy, it would look like Andromeda, where there's a big ball in the middle, but we don't see that big ball because of the clouds.
Oh, interesting. I'll have to look at a picture of Andromeda now, and with that in mind. So Andromeda is similar to the Milky Way in terms of the way it's organized in terms of the
I think in 3 billion years, we're going to collide with Andromeda.
Have we
And,
started already? I mean, aren't we
well-
kind of tingling our outer stars so far?
it's the next closest large galaxy to us, and it's heading right toward us, and we're heading right toward it.
Oh
at the same
boy,
time.
are you ready to show us what you got here, Al?
Yeah, I wanted to show you, we've had a lot of ground-based telescopes looking at the bulge in the center of our galaxy.
Uh-huh.
And I put together some information that kind of shows you what it looks like.
Oh,
Okay.
and so
this
is
is a,
that violet light part of our
Yeah,
galaxy
if you look
too?
at the center of the horizontal line is our galaxy on edge, and this is the bulge in the center, the white area in the center. And above the bulge is this massive gamma ray and X-ray emission zone.
Wow.
You know, so it's emitting a lot of gamma and X-ray radiations
Interesting.
that go out into a further sphere on both sides of the galaxy.
That is amazing.
Yeah.
So cool.
50,000 light years out, you know, for that. Okay, now I'm going to animate it here.
Uh-huh.
Yeah. Okay, we go into the galaxy towards the center. There's a lot going on in the bulge, as you can see. It's a party going on there. There's hundreds of millions of stars. Getting closer, a little bit closer. And as we get really close, you can see there's this black hole there in the center. That's Sagittarius A.
Oh boy.
Yeah. But the journey in, too. I mean, there's a lot that goes on in every step of the way. There's a lot to unravel as to what's what. And, like, for example, just before you get to the black hole, it looks like there's a white streaks going around. Well, that's like a million suns vortexing into the black hole.
Oh boy.
Right?
Amazing.
It's just vortexing in there as just the screaming cries of their solar systems as they,
Jeez.
you know, get pulled apart. It's not even vapor. I mean, black hole
Well,
is.
they're accelerating beyond the speed of their limited form.
So when they speed up and they go into the event horizon of the black hole, all these stars turn into X-ray and gamma rays. I mean, they emit a lot just before they drop into the hole.
Oh, I see. That's their
That's when it
final
comes
cry,
from, gamma ray
huh?
and the X-ray.
That's
from
their
that.
what is the Klingon cry, or the Vikings when they're singing to Valhalla, that final scream?
I hear
For
you.
a star, it's a gamma.
Well,
gamma ray.
maybe it's the destruction of solar systems releases all the knowledge that solar system has collected and goes out into X and gamma radiations. Maybe those emissions have encoded information about the history of these solar systems.
Yeah, could be.
It seems like the universe wouldn't willy-nilly destroy data.
Yeah. It's very interesting that this diagram that you've got shows that there's a 50,000 light year dimension to the two mirror gamma ray bursts going north and south, parallel to the center of our bar galaxy there, perpendicular, not.
Yeah, that's how far out it goes. Yeah, which is interesting. It's almost as far out as the galaxy is wide.
Yeah, it makes it look like it's toroidal shaped on some level, or like there's a symmetry to it.
Galaxies have a whole anatomy.
Yeah, it's some kind of geometry that's perfectly harmonious.
A galactic being.
Amazing.
It's kind of like this. There's a spin to the galaxy into the black hole. There's a spin to it, and so the radiation of the X-rays and the gamma rays shoot up and down.
Right.
Yeah.
It's really cool.
I mean, there are actually planets being born here too. It's not just a death, right? There are actually nurseries in the bulge.
Wow.
So, yeah.
So we're turning the eye towards a whole new understanding of our very own galaxy.
Absolutely. Nancy Grace Roman Space Telescope. Nancy Grace Roman.
Uh-huh.
I guess we should look her up, huh? Okay, let's see if Aura's with us today. Are you with us today, Aura?
Yeah, I'm here. Hi.
Hey. Yeah, we just wanted to ask you about the Nancy Grace Roman Space Telescope. Now, who is Nancy Grace Roman?
Nancy Grace Roman was NASA's first chief of astronomy, the first woman in an executive role there. She's often called the mother of Hubble for championing space telescopes and laying the groundwork for the Hubble mission. The new telescope's named after her in recognition of that legacy.
No, I understand it's going to be looking at the bulge. Is it going to be studying mostly the stars in the bulge or the black hole or what? What's its focus?
It's mainly focused on the stars. Roman's Galactic Bulge time domain survey will watch hundreds of millions of stars in that crowded region, taking a snapshot every 12 minutes or so. The big goal is spotting exoplanets through gravitational microlensing, when a star or planet's gravity briefly magnifies a background star's light. It'll also catch transiting planets and do astroseismology on red giants to study their insides. As a bonus, it should find isolated stellar mass black holes floating around via microlensing too. But it's not really about the central supermassive black hole at Sagittarius A. That's more of a secondary target in one of the fields.
Thank you.
Okay, there you go.
All right. I was very surprised when we met Don Davis, who is a rather prominent and well-known space artist who used to go to a lot of the SIGGRAPHs, and we became friends over the years. And Don pointed out to me something that I should have been obvious, but it wasn't, is that most of the art that we viewed, most of the space art that we viewed was actually artists like himself who looked at this raw data from all of these star charts and, all of the information from pictures of stars. And they mapped those star data out, and then they applied scientific insight to actually paint what those things looked like. And that was largely the case of most space art until computers became more useful tools. Yeah.
And that reminds me, there was a contest for the best Milky Way pictures.
Oh, are you going to show some of those?
Yeah, there's in Popular Science
That was
magazine.
in Popular Science.
Yeah,
Oh,
these
let's
are
check
these
that
are.
out.
I picked a few of these to show you guys. Okay,
So that's from Chile, huh?
right. Yeah, that's the very large telescope array in the Cerro Paranal in Chile's Atacama Desert.
Mm-hmm.
They have really great viewing conditions there. Just like you feel like it's a seamless connection between the Earth and the sky there.
It looks like the Milky Way is a rainbow connecting two of their telescopes.
Yeah, right. It looks like they generating it.
And it looks like it has got a laser fin like a dolphin, like it's waving at us.
This is what a galactic generator looks like in action. There it goes. That goes out into the universe, and then there's the galaxy.
It's arcing. It's arcing between the two astronomy centers.
It's the space arc.
Space arc of galaxy proportions.
But in reality, over to the left is the Magellanic Clouds.
Yes, Magellanic.
Oh, right. I can see them. They're very small, but they're galaxies in themselves.
In and of
but
themselves. Yeah, satellite
they're
galaxies.
satellites of our galaxy.
Right, satellite galaxies. And you can see them in the naked eye if it's clear enough weather.
Mm-hmm.
Really?
Yeah.
But you have to be south of the equator to see them.
Yeah, you have to be south of the equator. Like you have to be in Chile, for
That's
example.
why they named them after Magellan. You have to circumnavigate the world if you want to see all the galaxies.
That's right. Yeah.
And they have 4 big telescopes in that complex there, each equipped with a huge mirrors, 8.2 meter mirrors.
Wow.
Yeah.
Fantastic.
And they also project sodium laser beams into the sky so that they can cancel out the atmosphere, interference. They're doing it.
Wow. Fascinating.
This is a place called Mount Cook.
Mount Cook
New
up
Zealand,
in
I believe.
Oh, in New Zealand.
New Zealand.
Okay.
Yeah. Mount
I was
Cook.
in Captain Cook.
Central Peak of a national park there.
Mm-hmm.
One of the most challenges was getting in the right position to do this.
Yeah.
And it was a difficult hike to get here. He had the photographer had to go through large washouts, unstable snow.
Yeah, it looks like he pitched his camera in the middle of an ice field.
Yeah, probably was.
I'd like to know more about these cameras. We should definitely see if Don Davis wants to come on and talk to us about how these astronomers take these amazing photographs.
Each one's a story in and of itself. The photographer was Owain Scullion, Owain Scullion, Milky Way photographer. You'd be mentioned being known as a Milky Way photographer.
Yeah, well, I think so. I mean, artists tend to like it when people know who they are.
Yeah, let's see the next one. This was
wait.
photographer Stefano Pellegrini. And he spent 10 days traveling through Botswana, living out of his car. And this is a remote desert landscape in complete isolation there. Nobody else. Though it does look like he's lighting up the tree with his with a flashlight.
Oh, wow.
If you look closely, you see one guy standing there.
Mm-hmm.
But those are the trees that look like they're from the Wizard of Oz or something. You know? They could come alive at night, dance. You know? Yeah. And he spent hours navigating the terrain, finding himself. This was in Botswana.
Oh, wow.
Yeah.
Cool.
The final image is a blend of one exposure for the landscape, 11 for the light painting, and a stack of 4 tracked exposures for the sky. Caldera Galaxy Panorama. This was the highest point of a volcanic island of La Palma. Beautiful terrain there, exceptional night sky conditions. It was called a panoramic composition. The goal was to include the blooming pink flowers, the Tagenast flowers, an endemic species of the island. Indigenous maybe. Is endemic the same as indigenous? I guess so. Using them to frame the full arc of the Milky Way. It was using the flowers for the frame. The summit itself forms a vast crater, which gives you these expansive views across the island, rising above a layer of clouds. You see the clouds?
Yeah. It's beautiful.
Yeah.
Totally beautiful.
It was the early summer when he took this, nearing the end of the blooming season. And he found just a few flowers that are still good enough and positioned for this amazing composition.
Yeah.
Yeah.
Wow.
Careful planning, timing. Well, this was called Galactic Gandalf by Evan McKay, Milky Way photographer of the year also.
Ooh,
Yeah, for this
Galactic
year.
Gandalf. Well, I
Yeah.
wonder how he got all those special effects.
Well,
It looks
he
like it
arrived
was-
after dark. He found that a seal had settled exactly where he wanted to set up his tripod, but it didn't want to move.
Oh, yeah. Well, I guess when it comes to arm wrestling with the seals win.
Yeah, it's clearly one of his preferred resting spots. The photographer was very patient. Evan just waited, and at some point, the seal just moved over a little bit to the left. So he was able to set up his tripod right near the seal.
It's so
But the main
very
thing
magical.
was to frame the galaxy. There is a seamless kind of intertwining between nature and the galaxy. But occasionally, it's kind of fun to mix in our species.
Especially when we're looking so magical.
That's
Cool.
right. That's right. So,
That's really fun.
so check it out. That's on our links page. All kinds of great shots.
DR
19
Future.
from this. They're all world class Milky Way galaxy photographers. What you're seeing, folks, is a simulation of an exoplanet that's recently been discovered. And it's unlike any exoplanet we've seen so far. This was featured in Nature, but it is a molten, sulfur-rich world that just defies normal planetary categories.
So it has lava oceans.
Yeah, lava oceans, right. Right.
Wow.
Yeah, it's called L98-59D.
These names are so memorable.
Right. Right. Here, this is a little bit of animation. The whole planet is molten like that. And it's very close to the sun. It's like our sun, only more orange, more orangey than our sun. It's a bit closer. See how big it is in the sky. Scary place. They don't think life as we know it could necessarily come from this. But then again, Earth had a period where it kind of looked like this. I think the Hades a time about 4.5 billion years ago, near the beginning
Yeah.
of our
Sure.
planetary existence.
Right.
So it had a dense, sulfur-rich atmosphere,
Mm-hmm.
and it
Which
smelled
means
like
it
rotten
smelled
eggs.
like rotten eggs.
Yeah,
right?
rotten eggs, if you could smell.
If you could get close enough to inhale, I imagine you'd burn your nostrils even trying.
This creates a huge greenhouse effect, which prevents it from cooling,
Wow.
and
That's
stays
pretty
hot.
cool. That's
And so
really
it can exist for billions of years. Just a magma planet like this for billions of years.
yeah.
That's truly a hell world, I would say, at least for biological life
Well,
as
it's
we
a
know it.
birthing. It's
Yeah.
the birthing of a world.
Well, there's that too, but yeah, I'm taking from a more classic perspective. I mean, this does not look like a place you want to visit, unless you want to just virtually visit it, and not have to feel
well,
the
let's
pain
say
of
I
it,
would
right?
not want to take my human molecules there.
Yeah, exactly. Yeah.
I might be willing to remote view it.
Yeah, exactly. Or I might be willing to go into a virtual submarine and see where some of these streams go down into the bottom, and
Could
have
you?
scanners.
Stay a
Well,
little
it's
Okay,
like going
I was
to a
looking at the screen
volcano.
here. I have to say.
Yeah.
It's very similar to going to a volcano and seeing
put that
an
up?
eruption
I did
live.
put
As long as it doesn't hurt, and then you can explore it at will.
Sure. Maybe we should rename AI since AI is getting such bad
Okay,
press.
such a bad-
Why don't we start calling it remote viewing?
Because remote viewing exists. I mean, didn't you know Elizabeth April?
But for
And she
people
goes
like us who
into
use our
states
tools,
of consciousness where you just remote view, right? And she says anyone can do it. Probably true. But most people just don't have the knack for it or
well,
the interest in developing
when we
that ability.
call up a live
Yeah.
camera view on our screen, aren't we remote viewing?
What do you think, Bobby? Is that a remote viewing?
Well, I guess in a sense it is.
But not the same way as like
Technically.
Elizabeth April does.
Well,
right? It's different.
she's not bound by time. I mean, she can remote view any place in the universe of consciousness. She's like those YouTube tourists who time travel, right?
It's interdimensional. She can. Time is not a limitation. You can go forward or backwards
Yeah.
in these different dimensions.
Yeah. I was just listening to Arthur M. Young last night, and he was describing the fact that our conception of science does not include an accurate description of time because time, he believes, is a value that cannot be captured in the same data system as position because, it's change. It's a measurement of change. We don't have a way of accurately describing it in the scientific universe yet. That's his big contention with relativity.
Arthur Young, one of the creators of the helicopter.
Yeah.
That Arthur Young.
Yeah, and an intellect who's had an influence on a lot of people in our community. There's a lot of Arthur M. Young
That's right.
fans.
He went from being an inventor to being a philosopher later on in life.
And he lived in Berkeley.
Yeah,
For many
invented the
years.
helicopter in the 30s and 40s.
Uh-huh.
Bell helicopter owned his patents, became
Right.
very rich from that, and spent all his time studying the nature of consciousness and reality.
Right. And published some amazing books that I'm just starting to read. I just listened to one of his lectures last night, and he was talking about the way that matter is what the scientific universe focuses on, but matter does not account for light and the fact that when you interact with light, your observation automatically tells you it's still uncertain where the light is after you're done scientifically observing it.
And one of the things about light is its complete freedom. If I were to release a photon from my finger at this instant, tick, a second later it would be 186,000 miles away and I wouldn't know what direction. That is what? It's total freedom. So we have this total freedom as a contrast to all this matter behaving according to laws.
This is how he approaches his understanding of physics and spirituality, and I'm very interested in learning more. Yeah, a little quick summary of my last night absorption of Arthur M. Young.
Yes. Did you ever see MASH, in the MASH movie TV series, the helicopters landing at the beginning with the stretchers?
Yeah.
Well, that was the Bell Model 47, the world's first commercial helicopter, and the whirlybird, and he had a big role in its design.
Yeah. What is it called? Something in the bar, the helicopter bar or something?
The control bar, the way it works, was his idea. Which is key because it's apparently really hard to fly a helicopter. It's like patting your belly and rubbing your nose at the same time.
Funny.
But then he started getting his philosophy. I think it might be worth getting into understanding how a helicopter works, just because it helps you understand his philosophical paradigm.
Sure.
Because he did call his ideas the PsyCopter. Like the mind, the PsyCopter.
Interesting.
So some of the principles that he undoubtedly discovered in flying apply to his understanding of what was known as his winged self.
Right. Interesting.
Choppered self.
Right.
Metaphor. Yeah. Curiously enough, he had gotten a special medal for his work in studying consciousness from the Franklin Institute in Philadelphia, which had a big influence on my upbringing.
Oh, right.
It's like a science museum in Philadelphia, and it's got all kinds of amazing things in it. When I was there, they had a human heart that you could walk through, for example, or a tic-tac-toe game you could play. One of the first computers was tic-tac-toe, believe it or not.
Interesting.
Which we were exposed to as kids in Philly.
Oh, yeah?
Yeah.
Oh, wow.
So the Foundation for the Study of Consciousness, I started it in Philadelphia.
Oh, okay.
I
have a lot to learn.
Yeah, right. So
having this tool of mythos, it could penetrate every operating system on the planet. For the banking system, it could empty the largest bank vaults. And
overnight. I know.
Not even overnight. I mean, we're talking within
hours,
5 minutes.
Seconds.
You have agents. I mean,
but you are talking about digital gold. You're talking about bits on a screen.
No, and I think he's talking about actual money.
We're talking money.
Yeah,
yeah,
not
real
just
money.
Robots.
This is Bobby's major cautionary tale here. Yeah,
how does all this money get moved from the banks?
Because
Mythos AI,
if they can crack the passwords and infiltrate any operating system,
so they're just going to send commands to all of the trucks to move the cash around.
Well, what percentage is in a truck that's actually on a bill?
What gets emptied out then? Like, I guess I'm not
clear
what
digits
gets
on the screen. Like,
well, that's what
90% of the money is not in coins or paper.
So if it's that easy to erase, how easy is it to put back? Right? I mean, I guess the idea is just that it's chaos.
No, but it's like doing a wire transfer. I mean, once the wire transfer has been done, you can't undo the wire transfer.
Why not?
Why not?
Yeah, well, I mean, as soon as you identify that it's a heist, why don't you just reset to yesterday's data?
It doesn't work that way, apparently.
Doesn't work that way, hacker son.
Well, I don't know.
But she likes to hack.
Level.
She's a hacker mind. This is how they think.
When you do a wire transfer, you can't undo it. The bank will tell you can't undo it.
Yeah, but that's their policy. It doesn't mean that there isn't some
can't be undone
program that can reset the digits.
Yes, the undone.
I mean,
software.
they're dots on a screen.
Yeah.
But North Korea has actually moved $10 billion worth of money, and it's gone to North Korea, and there's no way to get it back.
But can they spend it?
Yeah, and that happened 2 weeks ago. So that's and we're talking.
So who lost it?
Who lost it?
Yeah.
These were mostly some exchanges on the Ethereum blockchain.
Oh, so people who don't have governments behind them.
Well, the Ethereum.
But the SWIFT banking system, and the way it works and how you do wire transfers and how they balance access from one bank to another, with Mythos, you can hack that right now. Really, you can.
Because it
And
has
so
happened
if
already.
North Korea decided to do that, this would be an existential risk. This would be huge. This would be the end of banking.
Black swan event for banking.
Yeah. Yeah. So that can...
That's why they have that consortium, the Glasswing.
Yeah. This is the reason why they have the Project Glasswing. This is why they went directly to the banks first. They didn't go to the security companies and talk to them or the Pentagon. They went to the banks first.
Yeah.
And they said, you're at risk the most right here.
Sure.
This is existential.
I'm just such an old-fashioned human. I can't believe that something that has been manufactured during my lifetime and only exists in a digital virtual reality that is subscribed to by humans with all of their beliefs and habits and attitudes towards each other. But nevertheless, it is completely manufactured out of this crystalline matrix that's made purely of electricity and software and the cloud. It's hard to believe that in our physical bodies here on planet Earth, we can't recover from that. I guess we can. We just have to accept that there's going to be some chaos while we get used to the fact that the way we've been doing things isn't the way we can keep doing things.
What I think this is going to do is going to put us into the AI economy. And what's going to happen is we're going to have to reevaluate what is money and how it's going to be transferred from one person to another and how it's going to be equally distributed. And so how do we get into this abundance society where the robots are making everything? And there's a lot of people on the planet that don't have a cell phone. They don't have electricity.
And that aren't using the banking system. I mean, that's
right.
Like Julia Butterfly was pretty fascinating just a couple weeks ago when she was keynoting a local event here to save the Bay from the federal, presidential orders to start drilling in the Bay. But she announced that since the 70s, she has been protesting, or maybe it's the 90s, she's been protesting the use of our federal tax dollars for unauthorized military expenditures that do not represent the will of the people. So she's been refusing to pay her taxes. And since she's refusing to pay her taxes, she can't participate in the digital economy because, they'll just immediately confiscate whatever funds she uses in the digital economy. And so her life has been dedicated to relationships that don't involve going through the digital economy. People respond to the situation based on their unique priorities and their own habits.
And she's not, by all means, not normal, though.
Yeah, she's not normal. She's not the mainstream.
No.
We're not the...
But we do know a few people who want to stay off the grid, and it's getting harder and harder to do so. That much I agree with you on that. However, things are such that the grid itself, as it's currently structured, can become disassembled given software like Mythos AI. And disassembly is the order of the day in many respects. And then the question is that if everything's disassembled, do we have reassemblers? Do we have systems that will replace what's been disassembled in a way that hopefully is more equitable and fair to humanity as a whole? Is that something that could happen? And is that something that we have a hand in? Do we play a role into which scenario unfolds here?
Which we you talking about, man?
Yeah, I'm talking about the heaven on earth abundance. The one though you want to be in. Where everyone has a lot of resources. Elon himself says he sees a world where everyone gets what they want.
Yeah,
but it'll be everyone will be able to have anything they want. That's the good future. Of course, and in my view, that's probably 80% likely. So look on the bright side.
I think so too, but I do feel we have to have a human conversation with each other about how that all works. We are in a realm that is created by the machine elves, and we're trying to use it in a realm that was created by the biological elves.
Okay, yeah, there's things that need to be worked out, but that's half the fun, isn't it? You like to do that.
I do. I like
See,
to work
that's what
it
you're here
out,
to
and
do.
I'm raising these questions for the sake of
for a
us
future
being
discussion.
able to
Yeah.
make the world a more wonderful place by recognizing all the participants and how the power sorts itself out.
That's right.
Individuals always
not-
have free will.
It's always the humans with the AI combo that makes the most sense to us.
Space News.
Breaking news is that ESA and JAXA joined forces in a historic collaboration to protect the Earth from asteroid impact. One of our big concerns in life, right?
Oh, yeah, big time.
You know, the European Space Agency and the Japanese Aerospace Exploration Agency but have gotten together towards planetary defense by signing an agreement to launch the Rapid Apophis mission for space safety, or RAMSES for short. Rapid Apophis mission for space safety, RAMSES.
Meet RAMSES. ESA's space safety program is sending RAMSES to rendezvous with Apophis and study the asteroid up close as it is pulled and stretched by Earth's gravity. RAMSES will deploy 2 smaller spacecraft to help it record any changes to the asteroid's orbit, rotation, surface, and interior. With RAMSES, ESA is capitalizing on a unique opportunity to learn how asteroids react to strong forces, and how we could push one off of a collision course if we are not so lucky next time. When the world looks up to see Apophis passing overhead, RAMSES will be flying alongside, providing close-up images and learning how to keep Earth safe.
So they're going to launch it in 28, and it's going to rendezvous in 29, April 29, where it'll be passing incredibly close to our planet, just 32,000 kilometers out, smaller than the distance to the moon, closer than the moon, and it'll be an opportunity for us to study this asteroid up close, and will help us think about planetary defense in a more cohesive manner.
Cool.
All right. Like, what do you do? Remember in the movies, they used an atomic bomb to blow one up?
Yeah.
Not necessarily the greatest idea. You know, you'd have lots of little pieces that could rain down on Earth. Would not be good. Each of them.
Is there a chance that Apophis might hit us eventually?
Or something like it. I mean, there are a lot of these objects floating around, millions, floating in the solar system. So it's possible. It seems like they have many times in the past. Look at the moon, how pockmarked it is. Our atmosphere protects us from some of the smaller ones, but hey, what happened to the dinosaurs? And I'm sure that's not the only one. There's talking about 12,000 years ago, there was a big one that affected the floods for humanity that many of the biblical stories talk about.
Yeah, well, they say that Apophis, they don't expect it to endanger the Earth, but it is coming closer to the Earth than to the moon, and it's coming between the distance of the Earth and the moon, right? It's coming close enough to the Earth that the interaction with our gravity field is going to be very significant in the path that it takes.
Yeah,
And
it could
so
have
they're
some
not
interesting.
sure how accurate their calculations are.
But if you're interested in the stats, it's 375 meters wide. It's like a 1,000-foot asteroid. And something that big coming this close happens every 5 to 10,000 years. So yeah, you're right. It could affect our gravitational forces. It'll give us a chance to see how gravity interplays with the asteroid. And looking at its structure and surface, too, gravity is going to have an effect on that.
Yeah, and I think it's supposed to be hitting the closest point to Earth on a Friday the 13th in August or something like that. Yeah.
Friday the 13th.
Yeah.
Get ready for Apophis. Friday the 13th.
Like a blockbuster movie.
Yeah.
Yeah. Well, ESA are going to be the ones doing the operations.
Mm-hmm.
And the Japanese the JAXA folks, they're mostly responsible for some of the sensors, like the infrared imager, and they're responsible for the solar arrays, and I guess they'll be tracking it to some extent too. I don't think they're planning to throw anything at it, though. I don't think they're trying to change its orbit.
Probably not, but I
yeah.
imagine that their earlier experiments with seeing if they could affect the trajectory of an asteroid did come from trying to anticipate what to do, just in case.
Yeah, yeah. Yeah.
The sun is having these coronal holes and immense solar mass ejectas that are happening as we speak now. And so they're worried in a couple days some satellites or some
that reminds me. Don't you have something from Stephen Burns that we're going to look at today? Oh, you don't want to go there yet?
Yeah, we'll go there at the end. It'll be the last thing we do.
Okay. All right.
The last thing we'll do is Kristen.
Okay. Thanks for that little reminder.
Yeah,
Brian.
got him.
We'll get back to it.
Yeah, we will.
What else you got here?
That the NASA Psyche mission just going to be flying by Mars for a gravity assist. That's a big NASA moment. That's a boost. That's where we're on their way to the asteroid that just might change everything. It's solid metal. It might have more gold and platinum than the entire Earth. And we'll be finding out in a couple of years. But right now it's getting a gravity boost by slinging around Mars and getting some great shots of Mars in the process. Mm-hmm. Yeah, they're going to use an imager on board. They call it the multispectral imager, which will be capturing thousands of pictures of Mars. And this will help hone in the data and that they'll need as it approaches Psyche in late 29. Mm-hmm. Yeah, because they want to get a lot of close-up pictures of this little puppy.
Yeah, we want to see the glistening gold on the surface.
That's right. So we want to see the kind of resources our solar system has to offer us here. Aren't we so focused on it being ours?
That's a long way to go digging for gold. Yeah. It's going to be hard to get it back here.
Unimaginable how much gold, silver, platinum is on this asteroid.
It is.
It would change. We would all be abundant. We would all be billionaires, each person on the planet.
Yeah, if gold held its value.
If you could sell that gold.
Yeah, if it held its value.
If there's as much gold as there is grains of sand on the beach, how does that affect us?
Oh, it does. It does. It fixes you so that the value abundance. Isn't based on scarcity anymore.
Mm-hmm.
Yeah, it's based on abundance.
Yeah, and also the true value of gold is as a conductor. I mean, it would make better wires than copper. If we could afford it.
Oh, yeah. I didn't know that.
Yeah,
that's cool.
Yeah, it's got a lot of principles.
No, it's the best electrical conductor. It's better than silver. It's better than copper. Gold is the best.
Yeah, so that's what will happen. Things will be used for what they're good at.
Okay.
Yeah.
You remember the Superman comics? There's a thing called kryptonite that could take Superman down.
Yeah,
remember
sure.
Superman kryptonite? And there was like green kryptonite and red kryptonite.
Oh. Yeah, I'm not really
not familiar with that? Yeah. Green kryptonite was the normal stuff that would just weaken Superman. The red kryptonite was the unpredictable stuff that would do strange things to him, like change him into another form. I bring this up because physicists have discovered an unknown crystal that they found in the grounds near the Manhattan Project's Trinity test.
Oh, yeah?
That happened out in the desert. That was the first atomic bomb that went off.
Okay.
Well, when it went off, it was on this big tower. It was a big tower that held the bomb, and it completely vaporized the tower and everything that was in it.
Mm-hmm.
And then vaporized a lot of the desert nearby, all the sand in the desert, and then created this new crystal in the sand called trinitite.
Wow.
Trinitite, 1,500 degrees Celsius, 2,732 degrees Fahrenheit.
First time ever found on Earth, huh?
It just aerosols all the metals that were in the tower, and that included hundreds of pounds of copper wire that were aerosoled and vaporized.
Wow.
So the geologists in the area have been finding weird reconfigurations of the desert after it melted and reformed again. The trinitite is probably the best known material that they found. And most of it's green, like in green kryptonite. And there's a little bit of trinitite that's red. And they just figured out that the reason why they have red trinitite is because of all the copper wire that was vaporized during the atomic blast and became part of the crystal.
I see. So it's part of the explosive apparatus.
It was a result of the explosive apparatus. It was a clathrate, a crystal that forms a geometric lattice work that is capable of storing other smaller molecules inside it, like a nanoscale cage. And from this new discovery led by an Italian geologist named Luca Bindi, it represents a new type of clathrate structure that actually has some magical properties.
What kind of properties does it have?
These crystals can act like a little parking garage, storing lithium ions within lithium ion batteries at the beginning and the end of charging and discharging cycles. Think better batteries. Red trinitrite.
Well, how common is trinitrite?
Well, it's very rare, but if it really works, if it really allows us to have
maybe we could start manufacturing some.
We could create trinitrite
like
through other
some
mechanisms.
Nuclear explosions on a nearby satellite planet where it's already hot.
Now you're thinking, it's a true entrepreneur here. But it underscores how rare high-energy events, like nuclear detonations, like lightning strikes, like hypervelocity impacts from meteors, all these are natural laboratories for producing new things. In this case, unexpected crystalline structures.
Wow, it gets you thinking what it's going to be like when we've become a solar system civilization, where we can take advantage of different kinds of temperature situations on nearby planets and moons.
Absolutely, yeah. Yeah, it's like the Egyptians melting metal and glass near the volcanoes in the Sinai Desert, taking advantage of the volcanism.
This is silicone creating cages that are dodecahedrons, which are 12-sided. This is Carl Sagan's dodecahedron idea.
Yeah.
And inside you have the lithium atom captured, or it could be copper. And based on what's inside that cage, it has a different color when the light goes through it because of the crystalline structure. It diffracts it with a different color because of whatever molecules inside that cage.
Oh, that's cool. Red if it's copper and yellow if it's gold or something. So the physicists have just discovered this?
They just discovered this, and they're looking at how it responds to electronics and storage of information. And who would have known that the first atomic bomb would create but red trinitite with copper in it to make a better battery? Who would have ever thought?
I mean, what's interesting is, you have copper on one end and you have lithium on the other. Their outer shell has a different number of holes in the shell that would either attract electrons or not, whether they're filled or not. And so electrically, it could have some very interesting properties.
Yeah.
And remember, red kryptonite.
Okay.
I'm dead for Superman.
Look,
where we started.
Isn't krypton, isn't it an inert gas? I should look on the periodic table.
All right, now let's ask Ara.
We'll
leave off
for Ara.
Yeah, let's see if she's
my picture of Ara.
Hey, Ara, could you tell us what was the difference between red and green kryptonite, and what did red kryptonite do to Superman?
Red kryptonite was unpredictable. It gave Superman different powers or weird personality changes every time, like turning him into a giant or making him evil. Green kryptonite was simple and deadly. It just drained his powers and could kill him.
Did Lex Luthor ever get a hold of the red kryptonite?
Yeah, in the comics, Lex got his hands on some artificial red kryptonite from Mr. M.Z. Spitlick. It didn't give the usual random effects, though. It straight up stripped Superman of his powers, letting Lex beat him up and toss him out powerless. Superman eventually tricked Lex into spilling the beans about MZY, which broke the spell and got his powers back.
Oh, that's right. Is that the guy that had to spell his name backwards? Get him to spell his name backwards?
Yep, that's M.Z. Spitlick, the little purple-suited imp from the fifth dimension. Superman always had to trick him into saying or spelling his name backwards to send him back to his own dimension. Drove the guy nuts.
Okay.
So you look on the far right column, and you'll see Krypton there in the middle.
Yeah,
Far
Argon
right.
above it and Xenon below it.
Yeah. I wonder why they selected that for his planet. I mean, he came
Krypton?
from a very
Kryptonite?
stable, inert gas.
I don't know. That's a good question. I wonder if there's ever was any scientist at DC Comics that thought that stuff up. Hey, Aura, you know the kryptonite in Superman, where did they get the name? Was it from Krypton in the periodic table of elements? Was there any connection between the periodic table of elements of Krypton and kryptonite? What do you know?
Yeah, there's a direct connection. The planet Krypton was named after the real chemical element krypton on the periodic table. Jerry Siegel and Joe Shuster picked it when they created Superman in the late 30s. The element was discovered in 1898 and got its name from the Greek for hidden, which kind of fits a distant, doomed planet. Kryptonite, the green rock, came later, first on the radio show in 1943, then comics in 49. They just took the planet's name and added "ite," like how you name minerals. So it's all tied back to that element. But it's not like they based the weakness on Krypton's actual chemistry or anything. It was just a cool-sounding word that fit.
Yeah, I guess it's back in those days, kryptonite or Krypton. It sounds pretty cool. It sounds very alien.
Yeah. I mean, there's a lot of people saying beware of upcoming earthquakes.
I know. Okay, we'll cover that just because you want to.
You promised. You did say you would.
Yeah, okay, here is
Stefan.
Stefan.
This dude.
He's talking about how there seems to be a bunch of earthquakes down by the Mexican border. I think right here. Hold on a second.
The Salton Sea
Valley, just south of the Salton Sea. You don't see this every day. It's not completely, we've never seen it before, 100% anomalous, but you don't see this every day. And this is following up after some pretty significant activity in Nevada, which is part of the Nevada seismic zone. And all these systems are linked together. Some really interesting geology, plate tectonics, and more, which we'll cover in today's video. We've also had some big solar activity today. So a huge solar explosion. It registered as a 5.7 M-class flare, but look at the amount of plasma that blasted off the sun today with this explosion, this sunspot group right here rotating towards Earth center and direct. It will be lined up with us exactly during our critical energy convergence that we have identified for mid-May. What does that mean? Well, it's when you have multiple things coming together, and typically when that happens, as we've been tracking on the channel and other people do it, I'm not the only one, whatever, you track this stuff, you see that when you have multiple factors aligned, they often work together synergistically, and it's sort of the whole is greater than the sum. So you'll have a big, very active sunspot, which has blasted off X-class flares in the past. It blasted off about 5 different coronal mass ejections towards Venus when it was aligned with Venus back just on the other side of the sun, just off the limb, the far side, rotating into view. That was a few days ago. On the 15th of May, we will have Mercury exactly opposite the Earth on the other side of the sun. This is a superior conjunction of Mercury, and we often see, like there's a very clear trend with superior conjunctions of Mercury, the planet closest to the sun, with the fastest orbital velocity, that angular momentum around the sun, with a magnetic field, that we get big solar activity. So we will have the sunspot right in line with us, and in addition to that, we will have this large coronal hole, which is perfectly correlated with the biggest earthquakes that we've had for the past year. Every single month in that position, Earth center direct and in that G effective zone. Check out that shock wave. If this had hit us, this would be a big solar storm. Very likely severe, almost certainly a severe geomagnetic storm. That's a G4 storm. The scale rating goes one beyond that to an extreme storm, and that certainly could have happened because that was a big explosion. Only registered as a 5.7 on the X-class rating, the X-ray flux rating, but the strength of a solar flare in terms of that designation is not one-to-one with the strength of the solar storm launched out. You see it's very high velocity. That shock wave is almost instantaneous. That would have been a big one. We could get a big one in just 3, 5, 7 days. That's really that time window from the 13th of May to 17th when this sunspot's really kind of tracking in this central zone, which we kind of call the Earth strike zone. Yeah.
Okay, it looks like we're in the Earth strike zone right now, huh? Thank you for that little update. You heard it here. I'm a huge fan of Stephen Burns. I really like his scientific approach to explaining what's going on with the sun and his ability to correlate different kinds of events with earthquake predictions, and his educational channel letting us know what he's paying attention to. It really helps all of us to have a little bit more scientific perspective about our planet and
I might add, he's also a bit of a metaphysician too. In all fairness.
Absolutely. He makes no bones about it. He's one of these scientists who integrates his spiritual life with his identity as a citizen on planet Earth.
Yeah.
You know, a scientist with a spiritual awareness.
And he's got a nice head of hair, and he would never wear a tinfoil hat.
Well,
I've seen him wear a tinfoil hat.
Have you really?
He's got a good sense of humor.
I'll send you the video.
Yeah, I'd like to see that. Okay, good. All right. Well, we'll see what happens.
Thanks for that.
We'll see what happens. All right. Well, thank you all again for being here this week.
All right, everybody. I hope you're having a great future now. And
yes, we will be tuning in next week if all goes well.
Continuing to wonder what the future is all about.
What the future. Here we go. See you.
Bye. Okay, I like that one.